Part 1. The ship hung in orbit above the blue planet for 3 days before Scholar Prime finally believed what her instruments were telling her. The readings made no sense. They contradicted everything she had learned in 200 years of studying primitive civilizations. The species below had nuclear power. They had sent machines to other planets. They had split the atom and mapped their own genetic code. By every measure used to judge a civilization, these humans should have been a serious and focused people, dedicated to the hard work of survival. But the data streaming into her ship told a different story. Stood in the analysis chamber, surrounded by floating screens that showed images from the planet's surface. On one screen, thousands of humans sat in a massive arena, watching 2 other humans move small pieces across a checkered board. The crowd cheered and gasped at each move, as if watching a battle for their very survival. But it was not a battle. It was a game. A simple game of strategy that the humans called chess. On another screen, young humans sat in rows, staring at sheets of paper covered in numbers and symbols. They were not calculating crop yields or predicting weather patterns. They were taking something called a mathematics examination, competing against each other for scores that would determine their futures. The mathematics itself was impressive, recognized advanced algebra, geometry, and early calculus, but the purpose confused her. They were not using these tools to solve real problems. They were using them to rank themselves against one another, like animals competing for status. The third screen showed something that made 4 hearts skip their rhythm. A human child, no more than 8 years old, sat alone in a room, arranging small colored tiles into patterns. The child was solving spatial puzzles, working through combinations and permutations at a speed that would have impressed a student twice her age. When the child finished one puzzle, she simply started another, harder one. There was no reward waiting. No food, no safety, no practical benefit. The child was doing mathematics purely for the joy of it. Had never seen anything like it. She called for her assistant, a young researcher named who had joined this mission as his first assignment. He floated into the chamber, his silver skin reflecting the blue light from the screens. "Look at this," said, pointing to the displays. "Tell me what you see." Studied the screens for a long moment. His expression shifted from curiosity to confusion to something like disbelief. "They have mathematics," he said slowly. "Advanced mathematics, but they are not using it correctly." "Explain what you mean by correctly." Gestured at the chess match. "This game, I have analyzed its structure. It requires calculation of probabilities, prediction of opponent moves, spatial reasoning across multiple dimensions of possibility. A child would need 30 years of survival training to develop such abilities, but these humans use it for entertainment. They gather in crowds to watch others think." And the child with the puzzles. "The same problem. She is developing cognitive abilities that our people would reserve for elite navigators or resource calculators. But she does it alone in her room with no purpose beyond personal satisfaction." Paused, struggling to find words for what he was observing. "Scholar Prime, is it possible that they do not understand what they have? Perhaps they discovered mathematics by accident and do not realize its true purpose." Had considered this possibility. It was the most logical explanation. Every spacefaring species that had encountered had developed mathematics the same way, through necessity. When your asteroid mining operation needed to calculate orbital mechanics or die, you invented orbital mechanics. When your colony ship needed to predict food consumption across generations or starve, you invented predictive modeling. Mathematics was the language of survival. It was sacred precisely because it kept civilizations alive. But as watched the humans below, she began to doubt this comfortable explanation. "Access their historical records," she ordered. "Find the origins of their mathematical development. I want to know when and why they created these tools." Worked for several hours, downloading and translating human data at a rate that would have overwhelmed a lesser computer. When he finished, his expression had changed. He looked disturbed. Scholar Prime, you should see this yourself. He brought up a timeline of human mathematical history, read through it with growing amazement. The humans had developed probability theory in the 17th century, more than 300 of their years ago. But they had not created it to predict asteroid impacts or calculate survival odds during disasters. They had created it to understand gambling. Two human mathematicians had exchanged letters about how to fairly divide the stakes in an interrupted dice game. From this trivial question, they had built the foundations of probability. Geometry was even older. The humans had developed it partly for surveying land and building structures, which made sense. But they had also developed much of it to solve puzzles, to prove theorems that had no practical application, simply to see if such proofs were possible. Calculus had been invented independently by two humans in the same century. They had used it for physics and astronomy, yes, but one of them had also spent years calculating the mathematics of curves for no reason other than curiosity about their shapes. Highlighted a particular section of the historical record. Look at this. They have a concept called recreational mathematics, an entire field of study dedicated to mathematical problems that serve no survival purpose. Puzzles, games, paradoxes, curiosities. They spend resources training humans in these useless skills. They give awards for solving problems that help no one. Zoomed in on an image from the human records. It showed an old human male, his face wrinkled with age, sitting in a small room surrounded by papers covered in mathematical notation. The caption identified him as a famous mathematician who had spent his entire life studying prime numbers, not because prime numbers helped his species survive, not because they were needed for any practical purpose, simply because he found them beautiful. Beautiful. The human records used that word repeatedly when discussing mathematics. They described equations as elegant. They called proofs beautiful. They spoke of the deep satisfaction that came from understanding a mathematical truth, as if understanding itself were a form of pleasure. "This is wrong," said. "This is all wrong. Mathematics is not beautiful. Mathematics is necessary. You do not find beauty in the calculations that keep your air recyclers running. You simply do them because you must." Did not respond. She was watching another video from the human surface. This one showed a large room filled with humans of all ages, sitting at tables with boards and pieces in front of them. They were playing a game called Go, which the computers identified as one of the most mathematically complex games ever invented. The number of possible positions in Go exceeded the number of atoms in the observable universe. These humans were casually exploring a mathematical space larger than physical reality, and they were doing it for fun. One player, a young human female, made a move that caused her opponent to stare at the board for a full minute before responding. When the response came, both players smiled. They were enjoying themselves. They were experiencing what the humans called fun, and they were having this fun by pushing their mathematical abilities to their absolute limits. Had studied 17 civilizations in her career. She had seen species that used mathematics to build empires and species that used it to destroy worlds. She had seen mathematics wielded as a weapon and mathematics used as a shield. But she had never seen a species use mathematics as a toy. "Prepare a full report for the High Calculation Council," she said finally. "I do not think they will believe us. I am not sure I believe us, but they must see this." "What will you tell them?" Watch the Go players continue their game. Watch them laugh and think and struggle and celebrate. "I will tell them that we have found something impossible, a species that treats mathematics like play, a species that discovered the most powerful tool in the universe and decided to have fun with it. The council will say they are not serious, that they are wasting their potential." "Perhaps," said, "or perhaps they will realize what I am starting to realize, that we have been doing mathematics wrong for 10,000 years, and these humans, these strange and playful creatures, have found something we never even thought to look for." Part 2. The High Calculation Council met in the Chamber of Necessary Truths, a vast hall carved into the heart of the. For 10,000 years, the greatest mathematical minds of their civilization had gathered here to solve the problems that determined survival. The walls were inscribed with equations that had saved billions of lives, formulas for atmospheric recycling, algorithms for predicting solar flares, calculations for distributing food during the Great Scarcity. Every symbol on those walls represented mathematics done out of desperate need. They had nearly gone extinct 7 times in their history. Each time, mathematics had saved them. They did not love mathematics. They owed their lives to it, which was different. One did not love the rope that pulled you from a pit. One simply held on with all your strength and did not let go. Stood before the 12 counselors, her report floating in the air between them. She had been presenting for 3 hours, and the counselors had grown increasingly restless. "You are asking us to believe," said Counselor, the eldest and most conservative member of the council, "that this primitive species has developed advanced mathematics as a form of entertainment, that they solve complex problems not because they must, but because they enjoy it." "I am not asking you to believe anything," replied. "I am showing you evidence. The evidence is clear." "Show us again the part about probability." Brought up the historical record once more. In their 17th century, 2 human mathematicians began corresponding about a problem. A nobleman had asked them to calculate the fair way to divide gambling stakes when a game was interrupted. The game was called dice. It served no survival purpose whatsoever. And from this trivial question, they developed probability theory. More than that, they developed expected value. They created the mathematical framework that we use for predicting uncertain events, one of the most powerful tools in applied mathematics, and they invented it to solve a gambling dispute. Counselor's expression shifted through several emotions. Disgust was prominent among them. "This is wasteful. This is irresponsible. A civilization with such potential and they spend it on games." But old Counselor, who had been silent throughout the presentation, finally spoke. "Tell us about the children again, the ones who solve puzzles." Nodded and brought up new footage. Human children begin mathematical play almost as soon as they can manipulate objects. They stack blocks to understand balance and gravity. They sort objects by color and size to develop categorization skills. They solve simple puzzles that teach them spatial reasoning. The footage showed a room full of young humans, perhaps 5 years old, sitting at small tables with colorful objects in front of them. The objects were geometric shapes: squares, triangles, circles. The children were fitting them into matching holes in wooden boards. "This seems like education," Counselor observed, "training the young for future service." "That is what we assumed at first, but watch what happens when the children master the basic puzzles." The footage shifted to show the same children a few years later. Now they were playing with complex interlocking pieces, building structures without instructions, creating patterns that pleased them. No adult was supervising. No test was being given. The children were simply exploring mathematical space because they found it interesting. "They are not being trained," said. "They are training themselves. They are drawn to mathematical problems the way they are drawn to food and social contact. It appears to be an instinct." The council murmured among themselves. This was deeply unsettling. For the mathematics was a discipline imposed from outside. Children learned it because adults made them learn it, because survival required it. The idea that a species might be naturally drawn to mathematical thinking was strange. It suggested that mathematics might be something other than a tool. It might be something inherent to intelligent life itself. "I want to see more of their games," Counselor said. "The ones that require advanced mathematics." Spent the next hour showing the council the full range of human mathematical games. She showed them chess, which required the calculation of countless possible futures. She showed them Go, with its universe of positions larger than the number of atoms in existence. She showed them poker, where humans calculated probabilities in real time while also trying to deceive each other about their calculations. She showed them video games, which were even more disturbing. Human programmers created entire virtual worlds governed by mathematical rules, and then other humans paid money to play inside those worlds. Some of these games were pure mathematics, puzzles that required optimization, timing challenges that demanded precise calculation, strategic simulations that rewarded long-term planning. Humans spent billions of hours every year engaging with these mathematical constructs. They have created artificial survival challenges, Counselor observed. They have made their lives so easy that they must invent difficulties to overcome. That is one interpretation, agreed. But I believe it is more than that. I believe they are practicing. Practicing for what? I do not know. But consider this. The humans who spend the most time playing mathematical games also tend to be the ones who solve their civilization's real problems. Their best programmers grew up playing games. Their best engineers spent their youth building with blocks. Their best strategists learned to think by playing chess. She brought up one final piece of evidence. It was a study from a human university, translated into. The study showed that humans who played strategy games performed better on tests of mathematical reasoning than humans who did not. More importantly, the game players reported enjoying mathematics more. They approached problems with curiosity instead of fear. They are not wasting their potential on games, concluded. They are developing their potential through games. Play is how they become good at mathematics, and because they enjoy it, they never stop. The council was silent for a long moment. Finally, Counselor spoke again. I would like to send researchers to the surface. I would like them to study these humans directly to understand how this process works. Perhaps we can learn something. Learn something, Counselor looked horrified. We are the most mathematically advanced civilization in this sector. What could these playful children possibly teach us? I do not know, replied. That is why I want to learn. The council voted and it was close, but in the end, its proposal passed. A research team would be sent to Earth. They would study human mathematical culture from the inside. Was assigned to the team. He did not want to go. The thought of spending months among a species that treated mathematics as entertainment filled him with discomfort. But orders were orders. He arrived on Earth during something the humans called autumn. The leaves on the trees were changing color, which the humans apparently found beautiful. Did not understand why chemical changes in dying leaves would be considered beautiful, but he noted it as another example of human strangeness. His assignment was to observe human mathematical education at all levels. He began with the children. At a human school, watched a class of young humans learning multiplication. The teacher used songs and games to help them memorize the basic facts. The children sang about numbers. They competed to answer questions fastest. They seemed to be having fun. Why do you make it enjoyable? Asked the teacher during a break. Would it not be more efficient to simply drill them until they learn? The teacher, a patient woman named Mrs., smiled at the question. We tried that for many years. It works, sort of. Children learn the facts, but they also learn to hate mathematics. They do the minimum required and never go further. When we make it fun, they want to learn more. They practice on their own. Some of them fall in love with it. Fall in love with mathematics. It happens more than you might think. I have a student right now, a girl named Maria who does puzzles for hours every day. She does not have to. No one makes her. She just loves the feeling of solving something difficult. She says it makes her feel powerful. Observed Maria later that day. She was 10 years old, small and quiet, with dark hair that fell across her face as she bent over her puzzle book. The puzzle was a type called Sudoku, which involved arranging numbers in a grid according to certain rules. The mathematics behind it involved combinatorics and constraint satisfaction. Maria worked through the puzzles with fierce concentration. When she solved one, she made a small sound of satisfaction and immediately turned to the next. She was training herself in logical reasoning, and she was doing it because she enjoyed it. Filed his report that night. He was beginning to understand what had discovered. The humans had stumbled onto something important. By making mathematics enjoyable, they had turned it from a burden into a passion. Their best minds did not burn out from stress or collapse under pressure. They thrived because they loved what they did. The implications were significant. They had been approaching mathematics wrong for 10,000 years. Part 3. The research team spent 18 months on Earth. During that time, they observed humans at every stage of mathematical development, from toddlers stacking blocks to elderly professors proving theorems. They attended chess tournaments and poker games. They watched children play video games and adults solve crossword puzzles. They interviewed mathematicians who spoke about beauty and elegance as if these were technical terms. His final report ran to 3,000 pages, but the summary was simple. The humans had discovered something they had never understood. Mathematics was not just a survival tool, it was a source of joy. And because it brought joy, humans pursued it with an intensity that no amount of discipline could match. The report caused an upheaval in society. Many rejected its conclusions entirely. They called the humans frivolous and undisciplined. They pointed to the many problems humans had failed to solve, the wars they still fought, the damage they had done to their own planet. How could a species that wasted so much potential on games be considered worthy of admiration? But others listened carefully. Counselor was among them. "We have been telling ourselves a story for 10,000 years, said in a speech to the full council. The story says that mathematics is difficult and painful but necessary, that our children must suffer through it because survival requires it, that there is no other way." She paused, looking around the chamber at the equations carved into the walls. "The humans have shown us that this story is not true. Mathematics can be joyful. It can be playful. It can be pursued not because we must, but because we want to. And when it is pursued this way, it flourishes beyond anything discipline alone can achieve." Counselor stood to object. "You are proposing that we change our entire educational system based on the practices of a primitive species, a species that cannot even agree on how to govern itself." "I am not proposing that we copy the humans exactly. They have their problems as we have ours, but I am proposing that we learn from them, that we ask ourselves whether our children might develop better mathematical abilities if they were allowed to enjoy the process, that we consider whether our own mathematicians might achieve more if they were not constantly driven by fear of failure." The debate continued for weeks. In the end, the council approved a small experiment. One school on one colony would try a new approach to mathematics education. They would use games and puzzles alongside traditional drilling. They would allow students to explore topics that interested them, even if those topics had no immediate practical application. They would try to make mathematics fun. The experiment was considered a failure at first. Test scores did not improve in the first year. Traditional educators pointed to this as proof that the human approach did not work for minds. But the researchers kept watching, and in the second year, something strange began to happen. The students in the experimental program started doing mathematics on their own. They formed clubs to solve puzzles together. They competed in friendly tournaments. They began inventing their own games, creating mathematical challenges for each other just as human children did. Most importantly, they did not burn out. Traditional mathematical education produced brilliant students who often collapsed under pressure in their 20s, their minds exhausted from years of stress. The students in the experimental program seemed to grow stronger with time. They approached new challenges with curiosity instead of dread. One student, a young female named, became particularly notable. She had been an average performer in the traditional system, showing little promise. But when given the freedom to explore, she discovered a passion for prime numbers. She spent hours studying their patterns, not because anyone told her to, but because she found them fascinating. By the age of 15, had discovered a new theorem about prime distribution that had eluded mathematicians for centuries. When asked how she had found it, she said she had been playing a game with herself, trying to predict where the next prime would appear. The discovery came not from hard work alone, but from playful curiosity. Such achievement changed the debate. If play could produce such results, perhaps it was worth taking seriously. Meanwhile, the research team on Earth had made contact with a human mathematician. Her name was Dr. Sarah, and she specialized in game theory. She was the perfect person to explain human mathematical culture to an alien audience. Counselor traveled to Earth herself to meet Doctor. They sat together in a small office at a human university, surrounded by books and papers and a chess set that looked very old. "I have read all your reports," Doctor said. "You find us strange because we play with mathematics, but I think the truth is that we find mathematics through play. It is not that we are wasteful, it is that we cannot help ourselves." "What do you mean, you cannot help yourselves?" Doctor picked up one of the chess pieces, a small figure carved from wood. "When I was a child, my grandmother taught me to play chess. She had survived terrible things. War, famine, loss. She had every reason to be serious all the time, to focus only on survival, but she said that games were how she remembered she was still human." "I do not understand." "When you are struggling to survive, every action must have a purpose. You cannot waste time or energy on anything that does not help you stay alive. But when you play a game, you are saying that you have time and energy to spare. You are saying that survival is not enough. You want to live, not just survive. Consider this. But your games involve mathematics. You are not just playing. You are thinking deeply, solving complex problems. Why combine survival-level thinking with play?" "Because that is when our thinking is best." Doctor set down the chess piece and leaned forward. "When I play a game, I am relaxed. I am curious. I am not afraid of failure because failure in a game does not mean death. And because I am not afraid, I can think more clearly. I can take risks. I can try strange ideas that might not work. Sometimes those strange ideas turn out to be brilliant." So play removes the fear that prevents clear thinking. Yes, and it does something else too. It makes us want to keep going. Mathematics is hard, really hard. There are problems that take years to solve, and most attempts end in failure. If mathematicians only felt stress and obligation, they would give up. But because we love it, because it feels like play even when it is hard, we keep trying. We become obsessed. We cannot stop. She smiled. That is the human secret. We do not do mathematics because we must. We do it because we cannot imagine doing anything else. And that is why we have come so far in such a short time. Return to with a new understanding. The humans were not frivolous. They were free. They had freed mathematics from the chains of necessity and allowed it to grow wild. And wild things, she knew, often grew stronger than cultivated ones. The experimental program expanded. Within a generation, mathematical culture had transformed. Children were still taught the survival mathematics they needed, but they were also given time to play. They invented games, solved puzzles, and competed in tournaments. They learned to love the subject instead of merely enduring it. The results exceeded all predictions. Mathematical achievement accelerated. Problems that had stood unsolved fell one by one, and the mathematicians who solved them reported something new. They were happy. They enjoyed their work. They wanted to keep going. They eventually made formal contact with humanity. The two species found they had much to learn from each other. They shared their knowledge of survival mathematics, the hard-won tools that had kept them alive through 7 near extinctions. The humans shared their culture of play, their puzzles and games, their ability to find joy in abstract thinking. Together, they discovered new mathematics that neither could have found alone. And as their collaboration deepened, a question arose that neither species could answer. Was mathematics invented or discovered? Did intelligent minds create mathematical truth, or did they simply find it waiting like buried treasure? They had always believed mathematics was invented, a tool created by necessity. The humans were not so sure. They had experienced mathematics as something beautiful, something that existed independently of practical need. Perhaps it was both. Perhaps mathematics was a gift waiting to be discovered, and the best way to discover it was through play. In the end, both species agreed on one thing. The universe was stranger and more wonderful than either had imagined, and the best way to explore it was together, with curiosity and joy, treating the most powerful tool in existence not as a burden to be endured, but as a game to be played. The old inscription in the Chamber of Necessary Truths was not removed, but a new inscription was added beside it. It was a human proverb, translated into mathematical notation. Play is the highest form of research. The children of both species grew up learning this truth, and when they looked at the stars, they did not see threats to be calculated. They saw puzzles to be solved, games to be played, wonders waiting to be discovered. Mathematics had been freed, and with it, both species found something they had been searching for without knowing it, the ability to survive not just with their bodies, but with their souls intact.